us the factors to take into account.
The first factor is the rate of star formation in our galaxy. Obviously, the more stars you make, the more potential abodes of life there will be. Some fraction of those stars will have planets. That's the second factor, the fraction which have planets. We then have to take into account the number of planets in each system which are potential abodes of life. The next factor is the fraction of systems of living things which give rise to intelligence. The next factor is the fraction of systems of intelligent creatures which develop high technology, detectable technology. But how long do they last? How long are they detectable? Perhaps they're destroyed by cosmic accidents. Perhaps in an ugly way through nuclear war. More likely, we think they become undetectable because they become so sophisticated in their technology that they don't waste any energy. They don't release energy into space, and therefore there's no sign of them to detect. And so we say, well, there must be some longevity. L, the length of time typically a civilization is visible. And now if we take the rate of production and multiply by that L, the end result is that thing we started out to find, which is the number of detectable civilizations in space.
The number is getting bigger. 7 new planets have been discovered in the last year. One almost as big as Jupiter by the 4th star nearest to the Sun. A planet orbiting star 51 in the constellation of Pegasus, and the giants near PSR 1257 plus 12. The latest estimate of the number of galaxies is now 50 billion. The number of detectable civilizations we might expect is 100 million. It's a pity our world is in the back of beyond. Only a handful of stars could have heard us yet. We may hear ET phoning first. SETI, the search for extraterrestrial intelligence, is listening out.
I made the first modern radio search in 1960. All over the world, large radio telescopes were being constructed because the beauty and power of radio astronomy had just been recognized. And also at that time, some very much more sensitive radio receivers were invented. The combination of these new telescopes and these new radio receivers gave us a sensitivity very much greater than we've had before. And this was a first. We had, in our abilities, crossed a very important threshold. So it made sense to search. It didn't require anything special in the activities of the extraterrestrials. If they were just like us, we could detect them. Conducting a SETI search from the Earth's surface is very challenging and very difficult. And the reason is you detect intelligent signals all the time. It's just they're all from us.
Have we ever detected an intelligent signal from another world? This man may have. Jerry Amon. At Ohio State University's Big Ear radio telescope, bigger than 3 football fields. From near the center of the galaxy. From a fixed source. An on-off signal 30 times stronger than the background. Heard on a single channel.
We had started a data run on August 15th, 1977 that lasted for about 3 days. As I was looking through the printout, I was recording and marking all of those signals that were unusually strong, and I came across one that was stronger than I'd ever seen before by many times. And I was so astonished that I wrote the word "wow!" exclamation point over in the margin without even thinking. To have signals coming in only one channel indicates the possibility that this was some either unique astronomical event or that it was generated by some transmitter. We are resurveying the sky using more modern equipment, and we have passed through that same region of the sky and have not seen the WOW source again.
They check their equipment and their figures. Studies eliminate bugs and glitches, stars, space probes, and terrestrial sources.
We have ruled out effectively nearby spacecraft or space debris or satellites in Earth orbit, and we've certainly ruled out anything close, very close to the radio telescope, like an airplane flying through the beam of the telescope. We have not ruled out the possibility that this is actually a signal from extraterrestrial intelligence.
Even if they can detect us, are there ways of covering the vast distances of space? Scientists have some exotic answers. Wormholes, for example.
If you imagine that this balloon is our universe, we live in 3 dimensions in the surface of the balloon. And it has been suggested that there may be what are called wormholes, that, if you like, sort of run across the balloon from one side to the other, or connecting points, which would allow us to travel from one side of the balloon via a shortcut to the other side of the balloon.
How about warping space?
Imagine that this sheet of paper is our universe and we're at point A and we want to go to point B. Normally we would have to travel through from A to B through the universe. What would be nice, of course, would be if we could find some way of bending the universe in another dimension to bring those 2 points together and then step across the gap. And that's a sort of space warp, if you like, warping the universe to bring those points closer together.
The answer remains theoretical. For us, we are limited to sending probes into nearby space, to gather information, to photograph and measure atmospheric conditions. Could others be doing that too? The most fervent UFO believers say it's already happening. They claim footage taken on board the shuttle Discovery in September 1991 shows an alien craft taking evasive action from one of our missiles. The space battle has commenced. Watch again as the intergalactic invaders engage warp drive and alter course in the blink of an eye. Obviously, the force is not with us. There is another explanation.
And in fact, the very same physical process that caused the space battle is behind the comet that's overhead tonight, the brightest comet in the last 20 years. Now, how does a comet relate to this space battle photographed from the shuttle? Well, the comet is a rocky object with a lot of ices. And when it comes in near to the sun, the heat from the sun causes the ice to sublimate, to turn into vapor. Now, this produces forces on the comet which tweak its orbit and make it very hard to predict the orbit of a comet. The shuttle carries 5, 6, 7 people into space every time it goes up. And those people in the shuttle do exactly what we do on the ground. They breathe, they eat, they drink, and they eliminate. They use the bathroom. The shuttle accumulates all this wastewater. Periodically, it dumps the wastewater overboard. When you dump off this wastewater and it turns into ice, what's going to happen to it? When you come into a part of the orbit where that ice can be hit by the sun, now you've got all these little ice crystals. They're hit by the sun. They start to sublimate. That is, they go from solid ice to gas. When that happens, it creates a jet. That creates a force. In essence, a little mini rocket engine, much like on the comet that we've seen, but it's certainly not a space battle from, creatures from Zeta Reticuli or wherever.
Our probe Pioneer is leaving the solar system. What would ET's probe look like? Perhaps like this meteorite seen by the Spacewatch team at Kitt Peak, Arizona. In 1991, by chance, they spot a potential alien craft. Possibly an alien space probe on a reconnaissance mission. 10,000 could pass each year. We would be lucky to notice a single one. So we watch and wait and wonder